Okay, this is the video presentation of your Module 5 review in Integrated 1. I hope you enjoy it. It covers every standard in Module 5, and I think it's a good representation of everything you need to have mastered going into this exam. So let's take a look at number 1. Write in slope-intercept form 4x plus 3y is greater than or equal to 12. All right, so essentially all you need to do here is solve for this y right here, all right, because slope-intercept form is y equals m times x plus b, where m is the slope of your linear equation and b is your y-intercept. So let's solve for this y right here. Well, the first thing we'd have to do is get rid of these 4x's, so I would begin by subtracting 4x from both sides. Just like that. Now, when you add or subtract, that does not affect your inequality, so let's bring down the greater than or equal to, and 4x minus 4x is gone, leaving us 3y on the left. And on the right-hand side, you cannot combine negative 4x and 12. Those are not like terms. So let's write this negative 4x plus 12. Now, one more step. You have to undo this multiplication by 3 right here. So let's divide every term in this inequality by the 3. And now just simplify. And when you multiply both sides of an inequality or divide both sides of an inequality by a positive number, that does not affect the orientation of our inequality symbol, so we will still be greater than or equal to. And on the left over here, my 3's cancel, leaving me the factor of y, so y is greater than or equal to, and a negative over a positive is negative. I cannot reduce the fraction 4 over 3, so I'll leave that alone. And then don't forget that factor of x right there. Then plus, and 12 divided by 3 is 4. So 4x plus 3y greater than or equal to 12 in standard form can be written in slope-intercept form as y is greater than or equal to negative 4/3 x plus 4. These are the same inequality written in your two different forms. Now for number 2, they want us to go the other way. They give you an inequality in slope-intercept form, and they would like it in standard form. And standard form is that ax plus by equals c. Right there. Now, a couple things to be aware of. A, b, and c cannot be fractions, and a must be positive. So the easiest way to convert from slope-intercept to standard form is, do you guys see this divisor of 5 right here? Well, since we cannot have any fractions, why don't we just multiply this entire inequality by 5? So on the left, y becomes 5 times y, so 5y is less than, and if you multiply this first term on the right by 5, the 5's would cancel, leaving negative 2 times x. And then plus, and 2 times 5 is 10. Now we are one step away from being done here. All right, in standard form, you need your x and your y on the same side. So do you see this negative 2x right here? Let's add 2x to both sides and bring down the less than. And on the left, I now have 2x plus 5y is less than, and on the right, the negative 2x and the 2x cancel, leaving me my 10. And there is y is less than negative 2/5 x plus 2 written in standard form. 2x plus 5y is less than 10. Note, no fractions, and the coefficient of x is positive, so that is very acceptable. Now, number 3, find the x and y intercept of each. All right, so we have this equation in standard form, and typically to go from standard form to intercepts, all right, let's just do a little table, or you could write the points. All right, I typically do a table like this. And if I'm looking for the y-intercept right here, I let x equal 0. And for the x-intercept, I'm going to let y equal 0. So I tend to just put my 2 zeros in just like this. And this becomes nothing more than arithmetic now. If x is 0, 2 times 0, we lose that term. And we're left with negative 3 times y is 16. So to solve for y, you're just going to divide by negative 3. So y is going to equal negative 16 thirds. And usually we can do this right in our head, just like that. Now, the y0, well, I'm going to lose this negative 3 times 0, and that leaves me 2 times what number is 16? And you guys all know that 2 times what? That's right, 8. 2 times 8 is 16. So the y-intercept is this improper fraction, negative 16 thirds, and the x-intercept is 8. All right, so there's the first slide. Let's go on to slide number 2. Now we're graphing the solution to a system of inequalities. That means we're going to find 2 boundary lines, and then we're going to shade a region in the plane that's called the feasible region. So you start with your boundary lines, and these have been given to us in slope-intercept, so let's review our slope-intercept. All right, I like to start with my y-intercept of b. So in this first inequality right here, the boundary line has a y-intercept of 6. So let's go up to y equals 6. 1, 2, 3, 4, 5, 6. And then we have a slope of negative 2 over 3. Now remember, slope is rise over run. So if I have a negative slope, I'm going to rise, I'm going to drop. And in this case, I'm going to drop 2. So my rise is negative 2, negative 1, negative 2. And then I just run 3. 1, 2, 3. And another point on this line will be right there. And a boundary line, to graph a perfect boundary line, I only need 2 points. Now, for an inequality, I need to know, is my boundary line going to be solid or dashed? And if there's an equal sign, the boundary line must be solid. So get out your ruler and draw a solid line that goes through those 2 points. And there's your boundary line for the inequality. Y is less than or equal to negative 2/3 x plus 6. Now let's do the same thing for our second inequality in the system, where I see a y-intercept of negative 4, negative 1, negative 2, negative 3, negative 4, right there. And I see a slope of 1/2. So that means from this y-intercept, I need to rise 1, and I need to run 2. And I'll put another point right there. And now, notice this inequality, there's no equals. This is y is greater than 1/2 x minus 4. So that means the line that goes through these 2 points would have to be dashed, okay? Which implies no point on the dashed line is within the feasible region. Now, which region in the plane do I shade now? That's the easy part. Look at your first inequality, y is less than or equal to. Less than or equal to means I need to shade below the solid line. So I'm going to shade below the solid red line. And then greater than would imply we have to shade above the dashed blue line. So the region that is below the solid red line and above the dashed blue line would be this region right in here. So I'm just going to shade that entire region, and that's called my feasible region. Any point within this feasible region is a feasible solution to this system right here. All right, and remember, we cannot be on this dashed boundary line. We can be a point on the solid boundary line over here. Okay, number 4. Now they're going to give you the solution to a system of inequalities, and they would like you, oh, excuse me, this is not a system, this is just one inequality. So they would like us to write the inequality based upon this graph. So we're going to do the same concept here, all right? I see a y-intercept, and I see a slope. So I'm going to focus on slope-intercept again, y equals mx plus b. All right, and I always start this with my y, and then I look at my shaded region and my line. Notice that we shaded above the line, which will give me a greater than, and because this boundary line is dashed, there can be no equal sign here. So this is y is greater than, and then I just need my expression mx plus b on the other side. So keep it simple. All right, the slope. Well, what's the slope here? Well, if I go from this point to this point, okay, I'm going to rise -2, and I'm going to run 3. So I see a slope of -2/3. So let's see here. Looks like this is my fraction bar here, and there's again, I'm rising -2, so I'm going to put the negative out front and the 2 in my numerator. That's my rise. And then my run is 1, 2, 3. And then don't forget your factor of x. Okay, so y is greater than -2/3 x, and now all I need is my y-intercept, my plus b. And the y-intercept of that boundary line is +2. So let's just put a +2 there. And this inequality represents this graph right here. Okay, number 6. For the line 2x minus y equals 12, complete the points. You have to love a problem where they give you a coordinate and they're simply asking you to find the other coordinate. They've given us an x coordinate in both of these points, so I simply need to do direct substitution to find my corresponding y coordinates. So let's start with the first x of 0. That means this x right here is a 0. So if that x is a 0, 2 times 0 is gone, and that left me -y equals 12. Well, I'm solving for y, and if the opposite of y is 12, that implies y would have to equal -12. So this y coordinate right here, -12. Now, what if my x is -1? Well, that gives me a 2 times -1 right there. 2 times x, -1, minus y equals 12. All right, now let's solve for the y. So the first thing you need to do is say 2 times -1 is -2. So we have -2 minus y equals 12. And if you're solving for this y, the first thing you want to do is undo this subtraction of 2. So to undo subtraction, we add, let's add 2 to both sides. Bring down your equal sign, and the -2 plus 2 cancels, leaving you -y equals 12 plus 2 is 14. Now, just like the last problem here, if -y equals 14, that would imply y equals -14. So the y coordinate at this point right here is -14. All right, now complete the solution to the system. And, you know, we don't actually have to use elimination here because they've given us the y coordinate as 2. So that implies I should be able to substitute that 2 for a y in either equation and then solve for the x. So that 2, where do you want to put it? I'm probably going to put it with this y here, but I could do either. So I went -x plus 9 times y, and y is 2, has to equal 14, and now let's just solve for x. So -x plus 9 times 2 is 18 equals 14, and then you subtract 18 from both sides, and that leaves us a -x on the left. 18 minus 18 cancels, and on the right I have 14 minus 18, which is -4. Now, just like above, wow, they're really stressing this on this review. If the opposite of x is -4, doesn't that imply x would have to equal +4? So the x coordinate at this point is a 4. Now you might check both of them, and you could probably do this right in your head. Let's find out. So does -4 plus 9 times 2 equal 14? Well, that'd be -4 plus 18 And negative 4 plus 18 does equal 14. And let's try it up top here. 5 times 4 would be 20, minus 3 times 2, 6, and 20 minus 6 is 14. So we know we have to be correct. All right. Now, in 8 and 9, use elimination to solve the system. And given our time parameters, I took number 8 out, and so we're just going to focus on number 9 right here. All right? And they asked us to use elimination. So here's my system of equations right here. And I love to solve these with elimination. Unfortunately, I can't just add or subtract right now and cancel my x's or my y's. So we're going to have to manipulate at least one of these equations. So you take a look here, and 2 goes into 4 2 times, and 2 goes into negative 4 negative 2 times. So I'm probably going to take this top equation and either multiply by 2 or negative 2, depending on which variable I want to solve for first. So it looks like I'm probably going to multiply by 2 right here, because now watch what happens. 2 times the 2x would give me a 4x. And then 2 times the 2y would give me a plus 4y. And then 2 times 2 is 4. Now, here's my system right here that I can now, well, I have 4x and 4x right there. And I have negative 4y and 4y right there. So how about if I add them so my y's cancel? There you go. So now let's rewrite. Well, my x's, if I add my x's, 4x plus 4x, that's going to be 8x. And negative 4y plus positive 4y cancels. And on the right, I have a 28 plus the 4. That's a 32. So 8 times what number is 32? You probably know the x value right now. And it looks like I'm not even going to show the division here because it's that easy. So 8 times what number is 32? That's right, x equals 4. So that's the x coordinate of the point where these two original lines intersect. And now let's substitute this x value into, and I typically use the equation I manipulated because that is usually the simplest. Let's see if I did that. Am I going to make this x right here a 4? Looks like it. So let's go 2 times my x, which we just said had to be 4, plus 2 times our y equals 2. All right, so 2 times 4 is 8, and now we solve this two-step equation for y. We need to get rid of the 8, so let's subtract 8 from both sides, equals, and we have 2y equals 2 minus 8, that'd be negative 6. And if 2 times y equals negative 6, wouldn't that y have to be a negative 3? So that implies y equals negative 3. And if you're not comfortable making that jump, just divide both sides by 2, because negative 6 divided by 2 will give you the negative 3. Now, your solution to a system is an ordered pair. So let's write this as an ordered pair. And remember, an ordered pair, your x coordinate always comes first. X equals 4 and y equals negative 3. So this is the point where these two lines would intersect if we graph them. And that's our solution. All right, now we're going to solve a system, but this time we're going to use graphing. All right, and now remember, on the previous one, we solved the system with elimination, and we came up with the ordered pair 4 and negative 3. Remember, that is the point where our two original lines would intersect. So now, if they ask you to solve by graphing, you just graph both lines and approximate the point where they intersect. And remember, these are both in slope-intercept, a great time to use graphing, because we have y equals mx plus b. And you guys know, look at this first equation. Y equals 11x minus 6. My b is a negative 6. So that means the y-intercept of this first line would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Right there. And then my slope is 11, which is 11 over 1. That means I have to rise 11, so let's count this carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'm going to run 1 because 11 is 11 over 1, and slope is always rise over run. Now, this is an equation, so I just need the line. So I take out my ruler and I do the line that goes through those 2 points. And there's my first equation right there. Okay, now the second equation, the y-intercept is 11 this time. So let's find a y-intercept of 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there it is right there. Okay, now my slope is -6 or -6 over 1. Meaning we're going to rise -6 and then run 1. So rise -6, we're dropping -1, -2, -3, -4, -5, -6, and we're going to run 1, which puts us right on that point that we highlighted on the other line. Okay, so now let's draw the line that goes through those 2 blue points right there. And do you see the point where those 2 lines intersect? Well, what's that x-coordinate? Looks like the x-coordinate is 1, and the y-coordinate is 1, 2, 3, 4, 5. So that's solving by graphing right there. Isn't that cool? All right. And I'm a big elimination fan because typically if you solve a system by graphing, you don't get such a clean problem like this, and you're really approximating your solution. But I'm very confident that this baby right here is exact. Okay, hey, here's our story problem now. And this is a great problem. Number 11, write 2 equations and solve the system using elimination. So this is our typical story problem in Integrated Math 1. All right, we've got to translate this into 2 equations to create our system of linear equations. So at a local electronics store, some CDs are priced at $14 while others cost $12. Now I know to you this is a dated problem because you guys aren't running around buying CDs like we used to back in my day. All right, but it still makes for a great story problem here. All right, so I've got to think about, I have $14 CDs and I have $12 CDs. And what did I spend? $114. So I'm probably going to let X equal my number of $14 CDs. So 14 times the number of $14 CDs that I buy, all right, plus, and then I have $12 CDs, plus 12 times the number of $12 CDs that I buy. And how much did I spend total? Well, I'm going to skip this. I bought 9 CDs. I need to jump to, I spent $114. All right. Now, there is my first linear equation right there. Now, let's go back to Sabrina buying 9 CDs. Well, if X is the number of $14 CDs, and Y is the number of $12 CDs, then wouldn't X plus Y have to equal 9? That's pretty slick right there. You get all of that just with this little line right here. So we're going to say the number of $14 CDs that we buy, X, plus the number of $12 CDs we buy, Y, has to give me a total of 9 CDs. Man, I must have just been paid that high school job. I don't think I ever went to an electronics store and spent $114 on CDs. But this person, back in my day, this person would be living the dream. So here's my system now, right here. Pretty simple system. And this is a good one to use substitution, actually, because look at X plus Y. It'd be easy to solve for one of those. But I think they said elimination. So let's go ahead and do it. Okay, now, and by the way, let's say they suggest you solve a system one way, but you decide, hey, this method's going to work better for me. If you use your method correctly and you get it right, I promise I will do everything I can to give you every possible point on the test question. right? But if I'm using elimination here, well, I can't add or subtract and cancel a variable. So I am probably going to multiply this x plus y equals 9 by the smallest number I can to get my y's to cancel. So I probably multiplied by 12. Okay. Oh, I'm going to multiply by negative 12 so I can add rather than subtract. Okay, that's cool. So let's go ahead and do that now. So negative 12 times x will give me negative 12x's. And then negative 12 times y will give me minus 12y. And negative 12 times 9, well, a negative times a positive is negative. And let me see. 10 times 9 would be 90. And 2 times 9 would be 18. So is that negative 108? And if you're not sure, check on your calculator. All right. Now, my system is now, to me, 14x plus 12y equals 114. And then negative 12x minus 12y equals negative 108. I'm going to not need this middle one temporarily here. So I'm going to just get rid of that just for a second because I might use it later. And I'm going to add these two equations right here because that would cancel my y's. So let's add. All right, so 14x's plus negative 12x's, that's going to give me 2x's. And 12y plus negative 12y cancels. And then I have 114 plus negative 108, and that's going to be 6. So if 2 times x equals 6, wouldn't x have to equal 3? So that means we bought 3 $14 CDs. All right, so let's put a 3 right there. Okay, now that means, you know, how many $12 CDs did I buy? Well, I'm going to go back to this x plus y equals 9 right here because I can do this right in my head. If this x is a 3, 3 plus what number y is 9? And that would be a 6. So this tells me we bought 3 $14 CDs and 6 $12 CDs to spend our $114. Oh, that's awesome. All right, last problem on the review right here. Write a system of inequalities for the graph shown at the right. Now, notice something here. They are trying to show you this darker region right here. This is your double shaded region. All right, so this would be my feasible region between a dashed boundary line and a solid boundary line. So let's use slope-intercept again here because that's going to be real easy. And I don't know which boundary line I started with, probably the solid one. So let's see. Y. And if I'm using the solid line right here, here's what I'm thinking. Obviously, the double shaded region is below that. So I am less than or equal to, because it is solid. So I wonder if I went that route, less than or equal to. Yes, I did. And now all I need is my mx plus b for that solid boundary line right there. All right. So, and again, m is my slope, b is my y-intercept. So it looks like I have a y-intercept of 4 right there. And man, you know what? They kind of, with the shading, I don't have the typical grid lines. All right. So I don't know, just to be sure, I probably am going to go all the way down here for my next point on that line. Yeah, I did. And that's okay. So now take a look here. All right. To get from this y-intercept to this x-intercept right here, what's my slope? So aren't I dropping 4, which is a rise of negative 4, and then running positive 4? So again, I'm going to go to my definition of slope. It's rise over run. And with these 2 points, I am rising negative 4, and I am running positive 4. And now, again, I had to do that because I can't see grid lines right here. But now I can reduce that. Isn't negative 4 over 4 nothing more than negative 1? All right. So This line has a slope of -1. So I could write -1x, I could write -1/1x, or I could just write -x. And I'll write it like that, but you do what works best for you. Now, my y-intercept. Well, that I can clearly see the b here, and that's the 4, +4. So there's my first inequality to this system. Y has to be less than or equal to -x + 4. And that is everything on or below this boundary line right here. Now, the other one, well, that's a dash line, so I'm going to go y, and dash means I'm not going to have an equal sign. And note we shaded above the dash line for the double shaded region here. So that means we're going to have to be greater than that dash line. And note greater than, no equals, a dash line. We cannot equal anything on that line right there. So it just stays greater than. And now let's do the same thing we did before. Well, I see a y-intercept of -4. Let's see if I started there. I did, and there's no grid lines, so I'm going to go to this x-intercept of -2 right there, and I can just do my slope from there. So let's go slope. Well, I am rising negative again, -1, -2, -3, -4. And I am running from -2 to 0, so that'd be running 1, 2. And now let's reduce that. -4 divided by 2 would be -2. So our slope is -2. And if you want to write that as -2/1 so you can really clearly see your rise over run, you may do that. Now don't forget your factor of that x, m times x. Never forget your x. And then what's the b? It's the y-intercept. You guys see that? -4? There it is. And that is our review. So you make sure you have every one of these concepts mastered, and if you do, you're going to do a real good job on your upcoming tests. You guys all have a great day.